Hello everyone, welcome back to my channel, and in this video we are going to discuss module 3 important questions for BAI602. Subject name is machine learning. So here I'm not going to discuss I'm not going to cover the explanation because I got comment in the comment section. I have got that I should also explain the topics, but we don't have that much time and exam is near, and also I have lots of work, so I'm not getting time to record the videos, but I will make sure to make videos for the next subject exam. Okay, so anyways, I have covered important questions for module 2, module 1. So I'll complete the series for module 3, module 4 and module 5, and just come let me know which is the next subject, and I will make sure to give important question, and as well as I'll try to explain the concept according to the questions. But here I'll just, for minimal time, I have very minimal time to record and post it. And also I would like to tell you, so whatever topics I'm mentioning, you just read those topics, okay, without missing any topic, and it is very easy if you understand the concept called ANN, LWR, linear multiple polyn okay, linear regression, multiple regression, polynomial regression, logistic regression. Okay, if you understand this topic, it's very easy for you to write in the exam. And also here you can expect some numerical questions, okay, where you have to learn the formulas. Okay, and for these topics, you'll find the answers in my notes, okay, which I'm going to tell you by the end of the video where you're going to find out the notes. So yeah, so this is last minute preparation, right? So without missing any concept, you just start studying, okay? And here in this module 3, I've just specifically mentioned the topic names, okay? So I've not mentioned like how it is asked, like explain the k nearest neighbor. Okay, so here I'm specifically mentioning the keywords. Okay, why I'm mentioning the keyword is because based on keywords, you will be able to remember for this concept what answer you can write. Okay, that is the reason I have just mentioned the keywords. Okay, if anywhere this keyword is mentioned in any question, you just write down the answer what you know. Okay, and the students who study at very last moment, okay, before the day of the exam, so for them to, if they only go through the slides and whatever is mentioned in the slide, those points, those diagram, if you write in the exam, you are definitely going to pass the exam. Okay. And for the students who want to score distinction or above distinction, they can just refer the notes and as well as the textbook. Okay, to write the answers in detail. So yeah. So let's not waste any time and let's get started. Okay. So this is the overview of the module 3, where you have KNN, weighted KNN, nearest centroid, LWR. Okay, and so here you will have the comparison questions. For example, KNN versus weighted KNN, or else they can ask you comparison between weighted KNN versus nearest centroid. Difference between they can ask. Okay. And then they can also ask linear versus multiple regression, or the comparison between multiple regression, polynomial regression. Okay. So comparison based questions also you can get. And the next is numerical questions. Okay, where you are going to have the formulas. Using those formulas, you have to solve the problem, and the given data will be given, okay, in the table form. Okay, weighted k, and then they will give, and some data in columns, rows and columns they are going to give, and using those data you have to solve the numericals. Okay, so let's get started. Here is again, yeah, so this is just the syllabus. Okay, so first topic is similarity based learning. In that you have, okay, first let's understand. Okay, so let's see if something is asked like explain similarity based learning, you should know what all things it consists of. So in similar based learning you have KNN, weighted KNN, nearest centroid and LWR. Okay, and next is linear regression analysis. So here you have linear regression, multiple regression, polynomial regression, and logistic regression. Okay, and in numericals, you have formulas for KNN distance table, weighted voting, and regression line. And in comparison, they can ask LWR versus linear regression, MLR, which is multiple linear regression, and this is LWR is, I guess, linear weighted regression. Okay, and versus logistic regression. Okay, so these are just the overview for the module 3. Okay, so I hope it's clear for you, right? So next, here is the format how you're going to write the answer. So always start with the definition, then go with the diagram. If it consists any algorithm or equation, you just mention it, then example, and along with advantages or limitations, or you can also say disadvantages. Okay, so this is the flow of writing for 10 marks, because many students get confused, like they will just say explain the KNN based algorithm. So many students don't understand what to mention for 10 marks. So they can just follow this format to explain the answer. Okay, so yeah. So first question is explain the nearest neighboring learning. So here you can just explain what is nearest neighbor learning. Okay, it stores the label training sample instead of learning fixed equation. Okay, so nearest neighbor learning is very simple and powerful machine learning model. Okay, so remember this point or the definition for nearest neighbor learning. Okay, nearest neighbor learning is very simple and powerful machine learning model. Okay, this you can write the definition, and then you can continue with it shows the label training samples instead of learning a fixed equation. Okay, and for a new test instance, it finds the closest training samples, and then it assigns the class label of the nearest sample, and it uses the distance measure. Okay, so for distance measure, which formula it is going to use? Usually or commonly it is used Euclidean distance formula. Okay, and NNN, okay, nearest neighbor learning, is also called as lazy learning because prediction time work is high. Okay, or prediction time it is being delayed. Okay, so that you can just write. So and go with the diagram. Okay, so here you can see the clusters. Okay, so here you, let's say this is pass and fail, or positive values and negative values, and here you have one data value. So we have to find this data belongs to this class or this class. Okay, this blue color dots or this purple colored dots, it belongs to or not, that we have to find for nearest neighbor learn. Okay, so that is the thing. So here you can see this dot is more closer to negative or purple dots. Okay, so we will say, we will decide that using the Euclidean distance measure, we are going to test this data, and we will say after calculating, we'll say that this data belongs to this class or the purple color dots. Okay, so in exam you can just take this as a positive class and this as a negative class, and this test data where it belongs to is what we are going to try to find out using how? Using nearest neighbor line. Okay, there's just a simple general idea I'm telling. Okay, so it's very difficult to cover all the topics, but yeah, I should not. Okay, I'll just mention the important topics. Okay, because I have to cover the important questions for module 4 and 5 as well. So that is the reason I'm not explaining, and also due to time constraint. Okay, so that you people should study. Okay, so yeah, that's it for nearest neighbor learning. So here same thing, k nearest neighbor, that same thing it is. Okay, but here in the next question they have asked like a k nearest neighbor algorithm they have set. So you have to What is algorithm? You have to tell in process, right? What is the first process? What is the second step? What is the third step? What is the fourth step? And what is the fifth step? Okay, so here you can see first what it is going to do is it is going to choose the k value. Okay, it is going to choose the, in first step, what it is going to do, it is going to choose the k value and distance measure. Okay, next in the second step, what it is going to happen, it is going to calculate the distance for the test point. It is going to calculate the distance for the test point. Okay, to all training samples. Okay, second is it is going to calculate the distance for the test point to all training samples. Okay, and third step is sorting the distance in ascending order. Third step, it is going to sort the distance in ascending order. And next is select the k nearest neighbor. Okay, once you calculate using the, and what I said for distance measure, it is going to use which formula? Usually it is going to use the Euclidean distance formula. Okay, that is how it is going to calculate. And once it you have calculated, it is going to sort it in the ascending order. And the fourth step is it is going to select the k nearest neighbor. And then fifth step, it is going to apply majority voting and predict the class, which class it belongs to. Okay, this data belongs to which class? Either this purple circle dots or blue color dots. Okay, so it belongs to this class is what it is telling. Okay, so KNN is simple but sensitive to feature, scale, and large data sets. So what it means? One advantage is, okay, you can say that KNN is simple and powerful machine learning model, but it is sensitive when it comes to larger data sets. Okay, so when it comes to complex equation, it is slower. Okay, so that is the disadvantage for the KN. Okay, so this you can remember. I hope you are able to understand what I'm trying to say. I'm just trying to cover or explain it in very simple words. Okay, so that is how you can remember the answers, right? Yeah. So next is weighted KNN. So these two questions were okay. This is same, okay, and KNN. In one question paper they have explained, like they have told explain K nearest learning. Okay, and how does the testing instant find the closest training sample? Okay, something like that they have asked. Okay, but I have here why I'm mentioning only topic name is, if this topic, if you see anywhere, you have to write this answer only is what I'm trying to say. Here also they have specifically asked KNN. Okay, and in this question also you can if it is asked for 8 or 10 marks, you can write the steps also there. Okay, and in the second question paper they have asked specifically like explain the K nearest neighbor algorithm. So here also you can include these points as well as this, okay, along with the figure or the graph. Okay, so I hope you understood what is KNN. So this was normal KNN algorithm. Okay, now next comes the weighted KNN algorithm. Okay, so here what you are going to have, you are going to have the weighted K value. Okay, so let's see, here you have the graph. Okay, normal KNN. Okay, every neighbor has the equal vote. Okay, in normal KNN, every neighbor has the equal voting. Whereas weighted KNN, closer neighbors gets the larger weights. So here you can see this is the closer neighbor, right? So it is going to get the larger weight. Okay, and this belongs to blue color class, so it is getting the larger weight. So these are little far, so it is getting the less weight. Okay, that is what you can, how you can remember. Okay, closer neighbors gets the larger weights. Okay, in normal KNN, every neighbors has the equal vote. Okay, and here the closer neighbors is going to get the larger weights or larger weights, you can say. Okay, so common weight formula. This formula you have to remember. Weight equals to 1 by distance. It's not that difficult to remember, right? So common weight formula is weight is equals to 1 by distance. Okay, and then add weights class wise and choose the class with highest total weights. Okay, like this test data belongs to which class? uh Pass or fail, that we have to print. So here obviously you can see if you have the weight more, a larger weight for this neighbors, so obviously if we calculate, it is going to be belong to this class, right? So prediction equals to class with maximum total weight. So here 2.0 plus 1.2, what value you are going to get, plus next you calculate 1.8 plus 0.5. So if we calculate, you are going to get the highest or maximum value for pass class, right? So this test data will belong to the pass class. That's what I'm trying to say. So I hope it's clear. So this is the points which you are main points which you have to remember for weighted KNN. Okay. So yeah, so they can also ask you the problems for numerical questions for weighted KNN. So here is okay. So they will give you the table and this thing test data they will give. Okay, 7.6, 68, and using k equals to 3 they have given. Okay, so using the Euclidean distance formula, this is the formula. Okay, d equals to square root of summation of xi minus yi, okay, to the power of 2. Okay, so here you can see fail score, how it is calculated. Okay, it is 0. What is the weight? 0.91 plus this is fail, right? Fail class it is there, and one pass class you have. Okay, so 0.91 plus 0.50 equals to 1.41 you are getting, and for pass only one value you have, 0.59. So here I have just taken one example. So you try to solve the problem. Okay, this is not the only thing, you also have to calculate the Euclidean distance also. Here also you have to show the substitute the values and solve the problem. And then here you can see how it is calculated, like which class it belongs to for fail score and pass score. So which is the highest value? 1.41, right? If I compare to fail and pass score, so 1.41. So the test data which has been given, it will belong to the, so final predicted class. Okay, the test data will belong to the fail class. Okay, next is, okay, so give priority to try to solve the problems for KNN numerical. Okay, weighted KNN numerical is what I'm trying to say. Don't skip the part of solving the problems. Okay, and try to remember the formula. Okay, next is nearest centroid classifier. So first topic we covered KNN, okay, normal KNN. Second topic we covered as weighted KNN. And third I said that numerical problems for weighted KNN. Okay, so next is we have nearest centroid classifier. Nearest centroid classifier. So if you are getting question for nearest centroid classifier, so what you have to write? Find the centroid of each class by averaging feature values. Okay. For a new sample, compute the distance to each class centroid and assign the sample to the nearest centroid faster than KNN because only centroids are compared. Okay. So here you have the nearest centroid classifier. First, what it is going, these are the steps. Okay, for nearest centroid classifier. First, it find the centroid of each class. So here you have the positive class, here you have the negative class. So what I'm saying, it is going to find the centroid for each class. Okay, so here it is finding the centroid. So this becomes the centroid, C1 for the positive class and C2 for this negative class. For new sample, okay, this is the new sample. We have to take this test data, it belongs to this class or that class. We are going to find out using which algorithm? Nearest centroid classifier. Okay, so for new sample data, this is the sample data. Compute the distance to each class centroid. Okay, you have to use this new sample for this Centroid C1 and also for Centroid C2 class. Okay, and then assign the sample to the nearest Centroid. Okay, once you calculate, you'll get to know this test data will belong to this class or not. So which one is near? This is the near. Once you calculate for this, no, using this value test data, you'll get the value. Okay. Once you get that value, you will be able to find out which is the nearest centroid. Okay. So this test data is nearest to this C2 value or C1 value. That is how it is going to find out using how nearest centroid classifier. Okay, and next advantage is faster than KNN because only centroids are counted. Okay, so why it is faster? Because only centroid value is being compared with the test value. Okay, as simple as that I am trying to explain. I hope you understood. Okay, what is normal KNN, what is weighted KNN, and what is nearest centroid classifier. So this is how you can remember. I hope this is clear. You just let me know whether it is helping you or not in the comment section. Okay, the explanation, okay, short explanation, the way I'm trying to explain is useful or not. You just let me know. Okay, so that I can make video for module 2 and module 5 in the same way. Okay. Next is locally weighted regression. Okay. So LWR, initially I said linear weighted regression. No, it is locally weighted regression. Okay, it is not linear weighted regression. It is locally weighted regression. Okay. So next, here you can see these are the steps. Okay. So three topics we covered, which is KNN. Next is weighted KNN, and after that you had nearest centroid classify. Okay, next topic is LWR, which stands for locally weighted regression. Okay, so from here it starts with regression concepts. So regression method that gives more importance to the nearby samples. Okay, and a separate local model is fitted for each query point. Okay, so for each query point, and nearby points gets the highest weights, far points get low weights. Okay, and bandwidth controls the locality and useful for non-linear but locally smooth patterns. Okay, so here you can see, okay, highly local fit and smoother fit. So this is the key points which you have to remember for the locally weighted regression along with the diagram. Okay, and more detailed answer you will find it in the notes. I'll tell you where you are going to find at the end of the video. Okay, so just remember the diagram and these points. Okay, along with this thing. Okay, when it is going to be high and when it is going to be low. Okay, this is bandwidth. I'm talking about bandwidth. Okay, when it is going to be high and when it is going, okay, for highly local fit it is going to decrease, and for smoother fit it is going to increase. Okay, next is comparison. See, LW, I'll try to wind up soon because very less time we have to cover module 4 and 5 also. So yeah, so this is for LWR versus linear regression. Okay, so you can remember these points, and detailed video, your detailed notes you are going to find out in the website. Okay, website called vtusmartprep.com. Okay, and yeah, these are the points which you have to remember for the comparisons. Okay, and diagram also you refer there if it is available in the notes and textbook. Here it is not in the proper format, but yeah, still if you are unable, you have very less time and last moment preparation, just remember this. Okay, this global line for a linear regression, and locally weighted is this way. Okay, so that is how you can show the comparison. Next is introduction to regression. where you have supervised learning technique for numerical prediction. Input variables are independent variables. Features output variable is dependent variable or target. And examples you have to include, okay, marks, price, salary, temperature. And regression is not equal to classification. This is very important. Okay, regression is not equal to the classification. So classification we saw for KNN, weighted KNN, and nearest centroid classifier. Okay, so those are all classification, and this regression topic is completely okay. So I'm saying that regression is not equal to classification. Okay, output is continuous. Okay, input X you have regression model, and then it is going to predict the Y. Okay, it's going to predict the Y. So it can be asked introduction of regression. They can ask you for 8 marks or 10 marks. Okay. So simple linear regression you have. So remember the formula diagram, and along with this, okay, what beta naught represent is intercept. Then you have beta 1, which indicates the slope, and then goal, minimize the error between actual and predicted Y, and common error measure is squared error or MSE. Okay, so this is the equation Y is equals to beta naught plus beta 1x plus error. Okay, so in the last minute preparation, you can remember this keywords, formula, and this diagram for simple linear regression. Multiple linear regression, you have Y equals to B naught plus B1 x1 plus b2 x2 plus, okay, go on till bn xn. Okay, extension of simple linear regression predicts one continuous output using the multiple features. Each coefficient shows effect of one feature, and watch out for multi collinearity and scaling. Okay, so see here you have CGPA data, attendance, study hours, and project. Okay, which is going to go to the this model. Okay, this data you have, right? CGPA, attendance, study hours, and project marks. It is going to go to the MLR model. So what is MLR? Multiple linear regression. Okay, it is going to go to this model, this all data, and then it is going to train it using this value or the data inside this model, and then it is going to predict the marks based on this all data. Okay, example which predict the student marks using many factors based on his CGPA, attendance, okay, study hours, and project mark. MLR model is going to predict the marks for that particular student. Okay, so that is MLR. Next, we have polynomial regression. The formula is y cap equals to b naught plus b1 x1, b2 x2 plus b3 x3. Okay, so x square, x cube, okay, followed by, okay, so this is the formula for polynomial regression. And then you write the explanation, okay, adds powers for the input feature. So here x values is considered as input, right? So it is going to have the powers feature is what it is telling. Okay, and useful when linear regression underfits can model. Okay, this model can be non-linear curves. Okay, and high degree may cause overfitting. Okay, the highest degree can cause the overfitting. So these points you have to remember for the polynomial regression. Next is logistic regression. For that, you have the formula, and these are the points which you have to remember. Okay, used for binary classification problems, predicts the probability between 0 and 1. For logistic regression, you just remember here you are going to have the probability values, which is always between 0 and 1. Okay, use the sigmoid function. Okay, threshold value is always 0.5. Commonly separated classes separates the classes. Okay, example pass or fail, spam or not spam, yes or no. Okay, these are the example for the logistic regression, and this is the formula for it. And also remember the diagram. Okay. And next possible question is, okay, so here they can ask individual explanation, okay, or explain polynomial regression, okay. So wherever you see this keywords, now you have to explain these points, okay. So these are all asked in the previous year question paper. These topics questions are asked. Those topics only I have mentioned here, okay. Next, the possible question is they can ask the difference between. Okay, so if you read those concepts, obviously you'll be able to write the difference between, right? Multiple linear regression versus logistic regression. If you have read those concepts, here you can easily answer those questions for the comparison or difference between. Okay, so difference between or comparison between multiple linear MLR versus logistic regression or LR, they can say. So these points you can be basis on these points you can remember. Okay, so at last moment for revision now you can just refer this points. Okay, if you want I will try to share this PPT also in the website if possible. Okay, I'm not sure, or else you can just take the screenshot of it, so that at the last moment if you just refer the slides, these keywords, you will be able to write the points in sentence. Next is linear regression numericals they can ask. So remember the formula. Okay, and using the formula, substitute the values and then you will get the predicted y. Okay, in the previous slide, I have already mentioned the formula for linear regression. So you can take the value, substitute the value, and then you will find the y, predicted y value. So your most repeated question from model 2 is weighted KNN numerical, LWR, KNN algorithm, regression types, nearest centroid, and you just need to have the formula sheet for the distance, weights, regression, and sigma function. Okay. So 10 mark question trick is use the diagram, formula, and advantages, limitations you have to explain. So basically, sorry, basically start with the definition, then diagram. Okay, if it contains any formula, mention that, and then conclude with the advantages or the limitations. Okay, so compare KNN, weighted KNN, and nearest centroid also they have asked. So you can just explain the difference between this. Okay. Next is, yeah, so this is the formula sheet. Okay, you can take the screenshot of it to remember the formula for all of these topics. Okay, and okay, so whenever you have formula in theory, now you just try to explain what x denotes y, what y denotes. Okay, so that's it. So these are very important topics which you should not skip. Okay, this is the last slide. You should not skip these topics. So yeah, revision order. First we saw, before this we saw the normal KNN, then weighted KNN, and then centroid, nearest centroid, right? And then regression. So in regression you have many types. LWR, okay, MLR, which is multiple linear regression, polynomial regression, okay, and then the comparison or difference between those regression. Okay, and then followed by the logistic regression topic, and then nearest centroid plus KNN comparison questions they have asked. Okay, so here I have just mentioned the keywords, okay, mentioned in the questions. Okay, so concept wise you can start reading, and for this topics or for these questions, okay, you'll find the answers in the notes. And before concluding or winding up this video, I want to tell you, please do not forget to subscribe to my channel. It is going to, and also hit the like button, because it is going to motivate me to make such videos for you people. Okay, so I just need those kind of support. Okay, so yeah, so let me conclude this. So yeah, just go to vtusmartprep.com, create the account over here, and once you enter the details, click on sign up. Here I already have the account, so I'm just going to sign in. Once you sign in, just select the department, and once you select here, right now only machine learning is available. So click on the department, and here you can see resources, notes. Right now only notes are available. PYQ is not there. Okay, notes are available. So here you can find the solution. So right now I discussed about module 3. So here you can click inside the website, read inside the website, and here you will be able to find the notes. Okay, so these are generated nodes. Okay, so diagram are from the textbook only, but regenerated diagrams from your textbook, because I don't want any copyright issues. So that is why I've generated this diagram and notes from the. Okay, so I've yeah, so I've generated the notes using AI tools. Okay, but it is from the textbook itself. Okay, according to your syllabus textbook, it is generated. Okay, notes and as well as this diagrams. Okay, so if you remember this diagrams and the mentioned points over here, it is more than enough. So here you can see how many pages notes it is. 26 pages notes it is. Okay, so here you can see these keywords you have to remember. Okay, so at the end here you can see it is one page revision summary. Okay, summary is also available, applications. Okay, everything is available in this notes, like last moment preparation, what all things you have to remember. Those things are there in this notes. For more detailed answer, you can refer textbook. Okay. So yeah, that's it for this video, and do not forget to subscribe to my channel. And if you want know important questions from module 4, you can comment down on this video, and I'll try to make the video for module 4 and module 5. So thank you so much, and see you in the next video. Thank you.